Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 69 of physics. Today we are going to start a new unit, and that is unit number 12, and the name of this unit is transfer of thermal energy. Let us introduce this unit, and we will explain that what we are going to achieve in this unit. This unit deals with the three ways thermal energy is transferred from one place to another. In this section on conduction, we will discuss why some objects feel cold while others feel warm, even though they are at the same temperature. In the section on convection, we will study how thermal energy is transferred in media that are free to move. Lastly, in radiation, we will find out how thermal energy from the sun reaches us, even though there is a vacuum between the sun and the earth. Ladies and gentlemen, let us discuss the three processes of heat transfer. You can see I have written there are three ways in which thermal energy is transferred from one place to another. They are conduction, convection, and radiation. Uh, in the explanation, I will say when two bodies of different temperatures are brought in thermal contact, heat will flow from a hot body to a cold body until both bodies are at the same temperature. The bodies are then said to be in thermal equilibrium. Ladies and gentlemen, if there are two bodies, one of which is a hot body which contain a hot water, you can say, and there is another body which contain cold water. So when they are in thermal contact with each other, so it means that heat will flow from hot body. These molecules which are having kinetic energy will move to the cold body, and they will transfer and share that kinetic energy with the molecules on the cold end. And this process will continue until both the bodies are at the same temperature. When both the bodies are at the same temperature, then we say that these two bodies are in thermal equilibrium. When the two bodies are in thermal equilibrium, then the heat flow from hot body to the cold body will vanish, and no energy transfer will occur then. If you observe the figure on right side of your screen right now, it shows a group of people gathered around a barbecue pit. Everybody feels very hot due to the heat from the burning charcoal. How is it that the heat, which is thermal energy generated by the red hot charcoal, is able to reach the people without their being in direct contact with the charcoal? In this unit, we will look at how heat is transferred by means of three different processes: conduction, convection, and radiation. All three processes contribute to the transfer of heat from the charcoal to the people around. Ladies and gentlemen, you can see in this picture that there are people doing a barbecue party and they are not in direct contact with that pit, barbecue pit, but still they are feeling hot because heat generated by the charcoal is transferred to touch their bodies. How it is possible? This is the main theme of this unit. We will discuss that, and let us first we turn our focus to the conduction. In the conduction, we are first observing conduction of heat through solids. Now, to investigate the flow of heat through solids, let us perform an experiment. For that experiment, we need different apparatus. First, we will observe the consequences of this experiment, and then we will deduce a very important two concept from this experiment. The apparatus used in this is Ingenhousz. Ladies and gentlemen, this Ingenhousz was a Dutch scientist who discovered the photosynthesis. That is very famous name. Uh, this is the first one, and you can see on the right side of that picture that there is written Ingenhousz apparatus that contains a tub and rods of the same dimension but of the different materials, in which there are copper, iron, wood, and glass. So we need the second things in this experiment are rods of the same dimensions. Rods of the same dimension. Remember that the dimensions of these rods are the same but of different material. But of different material. The material are different, and you can see that the different materials are copper, iron, wood, and glass. Now we have to do a procedure of this experiment. First of all, you have to coat the parts of the rods. Coat the parts of the rods with wax. Yes, remember that you have to coat it with the wax on the outside of the tank, not the inside, the outside of the tank evenly with melted wax. you have to evenly coat these rods with the melted wax. Now, the second time, pour boiling water. Pour boiling water, uh, where you have to pour the boiling water into the bath. Into the bath. Okay, these are the uh, two steps you have to do while performing this experiment. Now, you have to observe the thing that what is going on. Let us write and learn our observation. In the experiment involving in-house apparatus, heat flows from a region of higher temperature to a region of low temperature. Ladies and gentlemen, because there is a very hot water inside the bath, so that side we will consider as the uh, hot end of these rod. The other side of rods which is away from the bath are considered to be cold one. And few moments back we discussed that heat always flow from hot body to a cold body. So in this case, heat flows from a region of higher temperature to a region of lower temperature. Therefore, the wax on the rods melts as the heat flows from the boiling water, means hot end, towards the cold end of the rod. As the heat is flowing, and remember, because all the rods are of different materials, so heat flow will be different as well. What actually we are observing, the wax melts the farthest along the copper rod, followed by the iron, then glass, and then wood. If we are taking it in another sense, we can say the length of unmelted wax is shortest for copper rod and longest for the wooden rods. These are the observations we did in this experiment. So, ladies and gentlemen, from these two observations, there are two very important conclusions we are getting, and they are: number one, heat flows through the material of the rod without any flow of the material. Heat flows without the flowing of material. Remember, ladies and gentlemen, that material is not going from the hot end to the cold end. You have to observe this as well. Now, the second observation we are getting is different materials conduct heat at different rate. I am writing this as well. Different materials conduct heat at different rate. And you saw that in case of copper, more wax is melted as compared to the wood and glass. So, first one is copper, they conducted more heat. Then it is the turn of iron, then wood, and at the last, glass also conducts very little heat. So, heat flows, number one, heat flows through the material of the rods without any flow of material. The process of transfer of thermal energy without any heat, very important, without any heat, without any flow of the material is called conduction. The process of transfer of thermal energy without any flow of the material medium is called conduction. This is called conduction. When heat is flowing from the hot end to the cold end, but no flow of material is observed, then this process is called conduction. In general, metals such as copper, silver, steel, and irons are good conductors of heat, while there are many other materials such as glass, plastic, wood, brick, wool, and in case of gases such as air, and in case of liquids such as water, are poor conductor of heat. Ladies and gentlemen, the second name for poor conductor of heat is insulator. Why is the rate of transfer of heat in copper much faster than in wood? The preceding experiments suggest that the mechanism of transfer of heat in good conductors may be different from that in insulators. So you saw through this experiment that how heat is flowing from hot end to the cold end without the transfer of material itself. That was the purpose of this experiment. Now let us study the mechanism that how in metal heat is transferred so quickly, and in case of wood which is non-metal the process is slow. Ladies and gentlemen, all solids, metals or non-metal, whether they are metals or non-metals, are made up of tiny particles called atoms, or group of atoms called molecules. They are tiny particles or group of particles. They are called atoms, and group of particles are called molecules. So, ladies and gentlemen, whether solids or metal or non-metal are made up of these two types of particles called atoms or molecules. However, there is one important difference between metals and non-metals. What is that difference? Metals contains many free electrons, which are able to move randomly between the molecules. For non-metal, there are few free molecules. In case of metals, there are many free molecules. So I am writing in case of metals more free electrons to move. And when heat is given to those material, then the electrons moves vigorously. In case of non-metals, no free electrons. They are tightly bound to the nucleus. So, for non-metal, there are very few free electrons. The figures which are given on the left side of your screen is given a look through the molecular theory of materials, and that shows that what happens to the copper rod, which is a metal, and wood rod, which is a non-metal. This is copper, and this one is wood. Wood is non-metal and copper is metal. When they are heated from one end, you can see that they are heated from this end, and there is a heat source also given here. So these are the heat sources. When heat is supplied to one end of the rod, the molecules of the hot end vibrate vigorously and jostle their neighboring molecules, making them vibrate as well. The sum of the kinetic energy of the vibrating molecules at the hot end get transferred to the neighbor. Yes, when these molecules vibrates, which is shown here, they are jostling the neighboring molecules, which is here. Those who are vigorously vibrating means that they are having much higher kinetic energy. When they collide with the neighboring atom, they are sharing their kinetic energy with that molecules, and as a result they lose their kinetic energy a bit by transferring it to the neighbor. And similarly, the second molecule is then starting vibrating rigorously. So they also transfer energy to the other molecules, making them vibrate as well. Thus, some of the kinetic energy of the vibrating molecules at the hot end get transferred to their neighbor. This process of passing heat from the hot end to the cold end by molecular vibration is common to both copper and wood. It is a relatively slow process of heat transfer if we compare it to another process which is called free electron diffusion. What is that? When the rods are heated, the free electrons in the copper moves faster as a result of having more kinetic energy. These fast moving energy carrying electron diffuse are spread into the cooler part of the metal and then transfer their kinetic energy to the molecules by colliding with them. This explains why the rate of heat transfer in good conductors is much faster than that in the insulator, which is also known as non-metal. Ladies and gentlemen, that was the conduction of heat through the solid. Is it possible that heat can also flow through liquids and gases? So we are going to perform another experiment and we will observe that yes, conduction of heat is possible through liquids and gases as well. Uh, the two mechanisms for conduction are molecular vibration and free diffusion. I have to write here the two mechanism. This is the nutshell. The two mechanism for conduction are molecular vibrations and free electron diffusion. The second one is free electron diffusion. The free electron diffusion. These are the two methods we discussed before going into the next topic. And there is another very important thing you have to know. Liquids and gases are poor conductor. Poor conductor of heat compared to solids. Compare to solids. Now let us discuss conduction of heat through liquids and solid. In liquids and gases, heat can also be conducted from a hotter to a cooler region. However, the process of conduction in liquids and gases is inefficient. They are not very fast. Heat conduction in liquids and gases involves the transfer of kinetic energy from fast moving atoms or molecules to slow moving ones through the process of collisions. Yes, collisions between atoms or molecules are not extremely frequent in liquids and even less frequent in gases where the atoms and molecules are even further apart. And that is why, because the molecules in liquids and gases are further apart from each other, so they are not disturbing each other very much as heat is given on one end. This explains why air is a much poorer conductor of heat than water. which in turn is a poorer conductor of heat compared to most solids. Yes, in solids we are having fast conduction, and compared to the uh, uh, gases and liquid, they are inefficient. Now, to see this conduction of heat through liquid and solid, let us perform an experiment. In the experiment, we need the apparatus, and those apparatuses are test tube. You can see that in the figure on right side of your screen now. And then we are having ice. Next one, ice with ice with a piece of metal gauze, with a piece of metal gauze. And there is another thing, Bunsen burner. Bunsen burner, you can also see it here, Bunsen burner. And we need water as well. Now, what will be the procedure for conducting this experiment? First of all, wrap a piece of ice with a piece of metal gauze and place it at the bottom of the test tube. Here you can see that it is ice wrapped in metal gauze, wrapped with the metal gauze, and that is at the bottom. Next, we have to fill. First of all, we have to wrap ice with metal gauze. The second step is fill the test tube, fill the test tube till almost full with tap water, with tap water. Yes, the third one is heat the test tube. The third part is heat the test tube, and where you have to heat it at the upper end, not the lower, at the upper end. Then in the fourth part, you have to do observation, that what you are observing. So in the fourth part, you have to observe. Let us discuss the observation. The water at the upper end of the test tube will soon bubbles, as you can see in this area, that it will be bubble and boil while the fingers holding the bottom of the test tube are till quite comfortable. The ice wrapped in the piece of metal gauze will melt very slowly, and that is because heat will conduct through this water and will reach to the ice, and that is a slow process. So when heat is reaching to the wrapped ice, then it will also start melting but very slowly. And what it is showing? Showing that the rate of heat transfer from the hot end of the water to the cold end is extremely slow. In other words, water is a poor conductor of heat. Yes, you have to remember that water is a poor conductor of heat. How? Because the ice at the bottom is melting very slowly. So it means slowly heat is transferred. Most liquid, only with the exception of mercury, are poor conductor of heat. Mercury is also a liquid, but that is good conductor of heat. Needless to say, gases such as air are the poorest. So I am writing gases are the poorest conductor of heat. Yes, this is another conclusion. Uh, Needless to say, gases such as the air are poorest conductor of heat, are good insulator of heat. You can also say that if it is a poorest conductor, then good insulator. For some of the everyday application and consequences, we will give a look to this topic of conduction later on. So that was the whole story about the conduction. In the next lecture, we will discuss convection in greater detail. So be with me for that detail, that what is conduction. Thank you very much for watching this video. Allah Hafiz.